Hello class, welcome to Algebra Lesson 5.4, which is all about transformations of piecewise-defined functions. By the end of this lesson, you should be able to graph and analyze transformations of the piecewise-defined functions. So we're going to talk about how all of the different types of graphs can be altered, kind of like how we can shrink them, stretch them, move them up and down, move them left and right. And these rules apply across the board to all of the piecewise-defined functions. Today in the video, we're only going to look at absolute value functions to learn the different rules, but these rules apply to all of the different piecewise functions. So they apply to the step functions. So both the ceiling and the floor functions. It gets applied to anything we've talked about so far. But like I said, today we're just going to focus on how these transformations happen with the absolute value graph, okay? So the first thing we want to look at is understanding a reflection over the x-axis and what causes that. So starting with the red function, it's going to be on every single graph to help you know what the parent function is, to help you know what the graph started as, okay? So f of x equals the absolute value of x. Looks just like this red graph over here on the left. If we want to reflect it, if we want to flip it over the x-axis so it opens down, all we have to do is add that negative in front of our absolute value symbol. So that negative there, with or without a number, so I mean right now there's a negative 1, but if it was like negative 5 or negative 1/5, that negative is what flips the graph, okay? So if you are presented with a question, which you will be in your homework, it'll say, describe the transformations that have occurred. And sometimes there's going to be multiple boxes that you can check. If there's a negative, you need to make sure you check the box that says it's a reflection over the x-axis. All right? Then let's talk about how do we move these graphs up and down. This is really similar to what we did back in chapter 3, where if we add or subtract a number after our absolute value, that is going to be a vertical shift. If it's positive, it will move it up. If it's negative, it will move it down. Okay, so you can see the red graph is the parent graph. That's what it started as. And then in the second one here, I said +3, so it went up 3. All of these graphs, the lines have a scale of 2. So that's why this is 2, 3. And then same with over here. The scale is 2 and then 3. So that is a vertical shift. If you do a vertical shift, let's talk about how does your vertex change, because there will be questions asking you about the vertex. So the vertex started as 0, 0, and now it's no longer 0, 0. It didn't move left or right, so it's 0, 3 on this graph, and then it would be 0, -3 on this graph. So whatever number's being added after or subtracted after the absolute value, that's the y value of your vertex. Remember, your vertex is the point, it's the turning point of your graph, okay? So example 3, we talked about a vertical shift. Let's talk about a horizontal shift. So again, the red graph is our starting point. My vertex is at 0, 0. Then this second graph, you can see it moved to the right, 2, 4, 5. So my vertex now 5, 0. And then here it moved 5 to the left, so it'd be -5, 0 for the vertex. And the way that you can tell that just by looking at the equation, the function, is the x changes it shifted left and right when a number's added or subtracted inside the absolute value. And the general formula is x minus, they typically use an h. It's just another variable to represent the horizontal shift. So if we were talking about f of x equals whatever value we want to put there, whether it's a -1, a +5, whatnot, and then like this. So since the general formula has a negative there, that's why if we plug a 5 in, a positive 5, it looks like a negative. That's why it seems backwards in our head. If we plug a 5 in, it stays negative because of the general formula. But if we, oh, my thing froze, there we go. But if we were to plug a negative 5 in, we would have x minus a negative 5, or that becomes x plus 5, and that's why the plus is actually what moves us to the left, okay? So if that's confusing, just try to remember that when you're doing a horizontal shift, it's flip-flopped, it's backwards. If you subtract, you're going to the right. If you add, you're going to the left. And this general formula that has to do with transformations, that's why, okay? So the k value is whatever you add on the end. That's what we just talked about in the last example. And then the h value is your vertex, okay? Or your x value for your vertex. All right, so we've talked about moving up and down. We've talked about flipping. We've talked about moving left and right. But what about when we make it kind of like steeper looking or stretched out, like kind of like flattened? So the red is what it starts as. You can see that this one has gotten kind of narrower, right? When it gets narrower, that's a vertical stretch. And that means that this number here is not a fraction, or it's greater than 1, I should say. So we have a positive 2 here. And if you're ever given a graph and asked what the change is, what you're going to do is you're just going to find the slope. So you can see I had to go up 2 and over 1. So that's how I got 2. My slope was 2. But maybe you went the other way and you said, hey, if I go like this, that slope's actually a negative 2. Why isn't this a negative? So remember that negative means that my graph gets flipped. So since it's opening up still, I know that this has to be a positive 2 there rather than a negative. Okay, then over here, I went up 1 over 2. You can see it's a fraction that's less than 1. That's why it looks like it's getting flattened. That's called a vertical compression. Okay, let's look at example 5 where we have multiple transformations happening. So here we have this graph, and we want to know how did it change from the starting. So I'm going to say just g of x equals, I see that it started opening up, it's now opening down, so I'm going to have a negative, and then it looks like it's kind of narrower, so I'm just going to check to see if I have a different slope. So if I look, I have a slope of, I go up 3 over 1, so I'm going to say my slope is 3, and then I'm going to say x minus, and then where did my x move to? It moved all the way over to here, which is 6. So I'm going to say negative 3 times the absolute value of x minus 6, and then it moved up 1, 2, 3, 4. So I would say plus 4. And then I'm done writing my equation for that. Let's try it with another one, because I know it can sometimes just take some practice. So this one I'm just going to call h of x. And I'm going to say, okay, it started with opening upward. It's still opening upward, so there's no negative. But it does look like it's maybe changed. And by maybe, I mean it looks a lot flatter, right? So I'm going to go up 1 and then over 1, 2, 3, 4. That's my slope. So I know that I have a 1/4, and it's positive because it's still opening upwards. And then x minus, and then if I just get rid of that pen to make it a little easier, I'm going to look and see how far to the left did it move. It moved -1, -2. So x minus -2, x minus a negative becomes plus, absolute value of 2. And then it moved down 5 units. So I am all done with writing an equation for that graph. Okay, so our last example for today is figuring out what transformations happen without actually looking at a graph. So you would start with, let's start with f of x equals -7x times the absolute value of x plus 3 minus 4. So I'm going to start with saying, okay, there's a negative out here. That's going to be flipped, or you can say reflected over the x-axis. And then this 7 is a number that's greater than 1, so it's going to be a vertical stretch. And then I have a plus 3, which tells me horizontal shift to the, remember when it's plus for a horizontal shift, that's actually to the left. And then this minus 4 tells me vertical shift down 4 units. Then over here, I have a positive 1/8, so it's not flipped over the x-axis, it's not reflected over the x-axis. It's a number that's less than 1, so this is a vertical compression. And then there's nothing with the x inside the absolute value, so it's not shifted left or right. And then it's vertical shift of 1. And it's going up 1. If I stop and think about what's my vertex here, since my x didn't move, the x stays 0, and then the y would stay 1. And if I go back here and think about the vertex, it went left 3, so that's a -3, and then it went down 4. So my vertex would be at -3, -4. Okay, let's do one last one. So h of x equals negative, so that's a reflection or a flip over the x-axis. And then we have a plus 10, so that's going to, inside the absolute value, that's going to be a horizontal shift left 10 units. And then there's no vertical shift because there's nothing added after. So then my vertex would be at -10, 0. Okay. Here is a nice little summary of everything that I've talked about today. If you have questions about any of those things, please be sure to reach out for some help. It is going to be a lot of memorizing and remembering what does what, okay? But still, if you have questions, don't hesitate to ask. I'm happy to help you. Have a great day.